Hello everyone, this video let's learn lesson 16. First, truth table. When we are deciding the statement true or false, we can use truth table. For example, if the statement P is true, and then the negation of P, not P, is false. When the P is false, the negation of P is true. Let's see the definition of conjunction. So the conjunction is P and Q. Decide P and Q statement is true or false. We can list the table. We need to find all of the combination of true or false of two statements P and Q. For example, when P is true, so the Q maybe is true, maybe is false. And when the P is false, so the Q maybe it is true or false. So we list all of the combination of true or false between P and Q. So in this table, horizontally, when the P is true, Q is true, then the P and the Q, or the conjunction, is true. And when the P is true, Q is false. The conjunction P and Q is false. When the P is false, Q is true. P and Q is false. P is false. Q is false. P and Q is false. In this table, we can do a conclusion. A conjunction is true only when the both simple statements are true. So which statement you see is true? The conjunction is true. When the both of the two statements are true, then the conjunction P and Q is true. Okay, let's see the example. The first example, the 3 plus 2 equals 5. The first statement is true. Okay, let's use some different color. Okay, this first statement, let's say P, it is true. And London is in England. Yes, it is also true. What is this? It is also true. You see, and yes. So this is conjunction. So truth and the truth. It is truth. Only both of the statement is true. The conjunction is true. So both simple statements are true. Let's see second example. 3 plus 2 is equal to 5. Yes, it is true. London is in France. False. So true and false is false because one of the statement is false, then the conjunction is false. The third statement is 3 plus 2 is equal to 6. Is a false statement. And London is in England. Yes, it is true. But we have one statement false, so the conjunction is false. So it is false. Next example, 3 plus 2 is equal to 6 is impossible, is false. And London is in France is a false statement. So false and false, it is false. Truth value is false. Both simple statements are false. Okay, let's see definition of conjunction. So for the conjunction table, the P and Q, we have all of the combination between P and Q. When P is true and Q may be true, may be false. When the P is false, the Q may be true, may be false. So all of the combination between these two statements. And for the disjunction, if disjunction is false, only when both component statements are false. So you see the disjunction, we only have one statement is false, is when both of the statement they are false, then the disjunction is false. Okay, let's repeat this. So when the P is true, Q is true. P or Q is true. P is true, Q is false. P or Q is true. P is false, Q is true, P or Q is true. So only if Q is false, P is false, P or Q is false statement. Okay, let's see the example. This one, 3 plus 2 is equal to 5. Yes, it is true. Or, that means disjunction. London is in England. Yes, it is true. True or true? The statement is true. Second one, 3 plus 2 is equal to 5. True. Or London is in France. False. But we had one true statement. That means this disjunction is true. Statement is true. Next example, 3 plus 2 is equal to 6. It is false. Or London is in England. So it is true. So false or true. It is true statement. Last one. 3 plus 2 is equal to 6. False. Or London is in France. False. So false or false. So the truth value is false. Both component statements are false. Okay, let's see next example. Let P and Q represent following statement. So let me ask you, the P is true or false? So in this example, 10 is greater than 4. Yes, P is true. And then Q, 3 is less than 5. Is also a true statement. Let's determine the truth value for each statement. I can list a table, but I don't have enough space. So for example, the first one, I can list a table. So this is P, this is Q, and then this is P and Q. P is true, and Q is also true. P and Q is true. I don't have enough space, so let's make it short. P is true, Q is true, P and Q is true. Second one, not P. Not P means false. And Q. Q is true. So this is a conjunction. So we have one statement is false. So this is a false statement. So P or not Q. P is true. Or not Q means false. This is true because one statement is true. Okay, next one. Not P means false. Or not Q means false. So false or false, it is false. So this question, the solution is true, false, true, false. Okay, let's see next example. Construct a truth table. So if I want to construct a truth table, step 1, as with all truth table, first list a simple statement on top. Then show all the possible truth value for this statement. For example, I talked about this in this video. So when the P is true and the Q maybe is true, maybe it is false. When the Q is false, maybe Q is true or false. So we list all of the possible truth value for the statements. Second step, make a column for P and Q. Oh, this one, I forgot to put a question here. Let me see, where is the question? Oh, here. So the question is, find the truth table for the statement not P and Q. P and Q. So if I want to find this, so the second step is make a column for the P and the Q statement. So make a column for this first. And last, we add the negation. Okay, the statement with the parentheses in not P and Q. So for the P and Q, when the P and PQ, they are all truths, P and Q is true. When the P is true, Q is false, the conjunction is false. When the P is false, Q is true. P and Q is false. When both of the statements they are false, the conjunction is false. Okay, so P and Q are true, so P and Q is true. Next step is add the negation. So the negation, not P and Q. So we just negate all of these statements, becomes opposite. False, true, 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 true. Okay, so we are done. We found the statement of not P and Q. It is not true that P and Q. Okay, let's do a practice. Next example. Use a truth table to find not P and Q is true or false. Okay, so this is a repetition, I feel, because this one repeats the previous example, but it give us more informations. So it says use the truth table to so it gave us the P and the Q. P is Harvard is a college, so it tells you that it is true. Second one, Yale is a college, so second statement is also true. So my truth table, the next column, I'm going to have P and Q. Last column is negation of P and Q. So if both of the statements they are true, so the conjunction P and Q is true, and the negation of true is false. So this statement is false. So if they gave us the value, they are both true. Yes, I'm using this method. If they didn't give us any information, I'm going to extend my truth table. So true, false, false, true, false, false, and then list a lot of put a lot of informations in this table. Okay, let's see next one. Construct a truth table for not P or not Q. Okay, what should I do here? Okay, first I'm going to list the all possible true or false for the P and Q. And next step, I'm going to find not P. Then I'm going to find not Q. The last step, I'm going to find not P or not Q. Okay, let's start from not P. Not P. So for the P column, we are having not P. They are the opposite. False, false, true, true. And how about the next column? Next column is not Q. So not Q. So let's negate the Q. So we are having false, true, false, true. Let me double check. Opposite, opposite, opposite. And next column, we are going to have okay, next column, we're going to have not P or not Q. So this is disjunction. So false or false, it is false. True or false or true, it is true. And true or false, it is true. True or true, it is a true statement. Okay, let's see next example. Construct a truth table for the following statement. then in the parentheses, we're having P and Q, or not P. So this one, we're having a long table. Let's see our long table. So first, in the third column, what am I going to do? I'm going to find what is P and Q. So what is P and Q? So P and Q, true and true, true. True and false, false. False and true, false. False and false, false. And next step, I'm going to find not P. So not P. Let's look at the P column. Okay, so for the P column, let's negate all of them. We are having false, false, true, true. And the last table, we are going to have P and Q, or not P. So what should I do? I'm going to do the disjunction with this column and this column. We're having true or false. It is true. False or false. For false or false is false. False or true. It is true. False or true. It is true. Okay. Let's see next example. So truth table for the conditional and biconditional. So the first one is conditional. So conditional table, we also list my true or false of the P and Q, the combinations in first two columns. So these two columns. And the conditional means if, then. So this notation if is if P, then Q. So for the conditional truth table, if P is true, then Q is true. So this conditional statement is true. If P is true, Q is false. This statement is false. If P is false, Q is true. Then we have the conditional statement. If P, then Q statement is true. P is false, Q is false. If P, then Q is true. So we can do a conclusion. We only have one false statement. Is when the P is true, Q is false. We have the false. Other statements, they are all true. So let's memorize, put some times here. And memorize for the conditional truth table. P is true, Q is false. Then the conditional statement, if P, then Q is false. Let's see this example. Construct a truth table for the statement not Q. If not Q, then is not P. Okay, we list the P and Q true or false table. And now I'm going to have not Q, not P, because here you have not Q, not P. And the last column, we are going to have the conditional statement. It is not Q. If it's not Q, then it is not P. Okay, in the first table, you can use different color. So not Q, we need to negate our Q. We're having false, true, false, true. And not Q, not P. So let's negate not the P. False, false, true, true. Okay, let me double confirm. All right. And for the first statement, if it is not Q, then it is not P. So we are having false, false, then the statement it is true. And the second one, so true, false. So we are having true, false. This is the only special one. We are having a false statement. I'm going to have false. Okay, next one, this conditional statement is false. So false, true. So if it is false, then it is true. So this statement is true. The second one is false. And last one, true, true. So we're having true. Okay, the answer of this question is all of these. Okay, let's see next example. Construct a truth table for the following statement. If I have the following statement, a complex one, we have in the parentheses P or Q and not P. This is my first statement. Oh, this is a conditional one. So how to read it? We say if P or Q and not P, then Q. Okay, we are having a big truth table. So in the third column, I'm going to put P and Q. And the fourth column, I'm going to put not P. And then we are going to put P and Q. P or Q and not P. Last column, I'm going to have bracket P and P or Q and not P. This is a conditional statement. If, then Q. So we have many columns. Okay, let's fill out the table. First, P or Q. So P or Q. Truth. So this is truth. P or Q, if we have truth, false, this is true. False, true. False or true, it is true. False or false, it is false. Not P. Not P, I'm going to negate the P. So let's negate the P. We are having false, false, true, true. And then we are going to combine these two together. So we are having conjunction, that is, and the relationship between these two statements. So we are having true and false, true and false. Then we are having false, true and false, false, true and true, it is true. False and true, it is false. Now we are having the conditional statement. We need to use which two columns? We're using this column and the Q column. Okay, if false, then true. Okay, this is true. If false, then false, it is true. If true, then true, this is true statement. And last one, if false, then false, it is also true statement. True statement. Okay, we finished the conditional statement part. How about the biconditional? So here we have a table, and biconditional is the symbol here. If only if. For the if and the only if, we are having this truth table. So P is true. Q is true. The biconditional statement is true. P is true. Q is false. The biconditional statement is false. The P is false. Q is true. The biconditional statement is false. The P is false. Q is false. The biconditional statement is true. Okay, we're having two true statements and two false statements. You must be very careful. So look at these two statements. So true, true, true. False, false, true. Okay, be very careful. And rest of the statements, we're having all false. Okay, let's see next example. Construct a truth table for the following statement. What should I do? I need to have another two columns. So the first column is not Q, and last column is not Q if only if P. So not Q here, and then not Q if only if P. Okay, for the not Q, negate the Q. False, true, false, true. And not Q if only if P. So we're going to combine this column and the P column together. And we have learned only the same true or false. Then we can generate this statement is true or is true. Okay, let's identify the same true or false. So true, false, this is a false. True, true, true. False, false, true. False, true, false. Okay, let's see. Next example. Let me double check if I have any mistake. False, true, true, false. Yes, no mistake. Next one, construct a truth table for the following statement. Okay, this is a complex one. We have P or Q if only if, not P. Oh, if, not P, then Q. So let's make a long truth table. The first column, I'm looking for P or Q. And next table, I'm going to find not Q. And next column, I'm looking for not Q. The conditional statement, if it is not Q, then P. Last table, I'm looking for P or Q, if only if. The second part of the statement is if not Q. Then P. Okay, let's see. P or Q. So P or Q, true. P or Q, true. P or Q, true. P or Q, false. Not Q. Let's negate the Q. False, true, false, true. And if it is not Q, then it's P. So let's look at these two columns. This column and the P column. So FT. FT is T. So TT, T. FF, T. TF, it is false. Okay, let's see the last part. Which two statements I need to combine? To combine. Sorry. So the first one is P or Q. This column, and the second column is here. Okay, so let's start it. So T, that is true. and true. Oh, it's another true. True. Another true statement. False is also true because this is biconditional statement. So they are all true. All right. Let's see the De Morgan laws. De Morgan laws. For the De Morgan laws, this is the negation, or we say this is a complement of the statement, or the opposite of the statement. We have learned this symbol. This is an opposite, or the complement, or the negation. If I have A and B, the complement of A and B is, if I want to clear the parentheses, inside of the parentheses, we have A and B. This is the conjunction. Then it becomes disjunction. So I distribute the negation to A to B and convert the conjunction to be the disjunction. Okay, if I have A or B and do the negation, we distribute the negation to the A to the B, and the disjunction becomes conjunction. All right, similar relationship applied to the statement of symbolic logic. So it is not true that P and Q, this symbol means equivalent to. It is not P or it is not Q. You see, if I distribute this negation, I change my and becomes or. If I want to clear the parentheses, distribute the negatives or negation into the parentheses, so P becomes opposite, Q becomes opposite, the negation. And the relationship between P and Q becomes, so from or becomes and. So this is very interesting, the De Morgan laws. So let's clear this part and see one example. So let P and Q represent the following statement. The first one is Phoenix is a state. Q, California is a state. So if I want to express this, it is not true that P and Q, I will say, it is not true that Phoenix and California are states. I can also distribute the negation into the parentheses, and my and becomes or. So I can say Phoenix is not a state, or California is not a state. Okay, let's practice another two examples. Use De Morgan's laws. Use the De Morgan laws to write a statement is equivalent to the following statement. So the first one is the word problem. It is not true that April and August are both spring months. Okay, so you see this is a negation of the statement 1. Okay, the first statement and second statement Q. So if I rewrite this one, I'm going to have not Q or not P. Not P or not Q. So let's do it. I can say April is not a spring month. Or August is not a spring month. Okay, let's see next one. If I'm using De Morgan law, I want to clear the parentheses. I can say this one is equivalent to Not R. What is not R? That is R, because you negate the R twice. You're having R. And you convert the or becomes and. It's not working. And, not P. Okay, this is the last question of lesson 16.